Okay, so I'm going to try to do this example from the data challenge in class and force myself not to talk quite as fast as I did before. So in order to do the cross-tabulation, we're looking just at the polity and durable variable. I think your homework assignment uses maybe democracy and autocracy, I'm not sure. But the first thing I would suggest to do is just to take the data and copy just the columns that you need so that you don't have these extra columns over here, and put it into a new sheet. So here I'm going to rename this sheet Reduced Data Challenge. Okay, so the two variables I'm going to deal with right now are polity and durable, and I'm just going to insert a couple rows up here that I can work with, and I'll show you why in just a second. Okay, so the first thing you have to think about is converting these into dichotomous variables, and that means that the variable is either a 1 or a 0, and it doesn't matter which one is which. You just have to be consistent, and you have to choose your cutoff point. So there are two potential options for a cutoff point. One would be a cutoff that's the mean, for instance. A different version could be median. Just remember that when you write up your analysis, you have to explain why you choose mean or why you choose median, and I'll talk about that in just a second. So for each of these, let's say we start with polity first, and you can calculate it by typing equals, average, and then I can just select everything in this polity column. Now to select the whole column, you notice that I clicked the first cell at the top and then I'm touching nothing. When I scroll to the bottom, if you hit shift and click it, I'm on a Windows machine by the way, it highlights the entire column, and then I insert the parentheses and hit enter, and it takes me here. So the average polity is 3, and the median polity is 6. So one of the things you could do when you have this information is you could look at any country in this data set that is around the number 3 and see if you feel like the polity makes sense. So note in the code book here that polity is a 20-point scale running from -10, which is completely authoritarian, to +10, completely democratic. And so what you want to do is look at this 3, look at things that are around 3, and say, okay, is 5, would you consider that a democratic country? And so you might find some that make 3 not actually a very good choice. Let's see here, 3, anything close to 3, here's 3. So do you consider Iran to be a middle of the road democratic country? Now, that interpretation is up to you. This is just a polity score from a separate data set. So you can look through some of these and say, okay, some of them might be a little strange, but here's a 4 is Malaysia, a pretty average democracy. And I see another 3, Peru. So if that's not a good marker of what you think should be the divide between democracy and not democracy, because note that you could also use 0 as the middle point, right? Anything 0 and above is democratic, and anything below 0 is not democratic. You can choose any of these breaking points. So you want to do the same thing for durable. You need to establish, and you don't have to do both median and mean. I'm just doing it for an example here, but I'll show you why you need these numbers in just a second. But for nothing else, they're good for going through the data and trying to see if that makes more sense, if the mean makes more sense, or if the median or the cutoff middle point of the entire range of data. So the median is the middle of the data, right? Half of the data points are above it and half are below it. The middle point of the range, though, is -10 to 10 for polity, and that means that the middle of the range is different than the middle of the data set. That would be the 0, right? There's half of the possible scores above it and half of the possible scores below it, not half of the actual scores above it and below it. Okay, so here I calculate the median of durable, and this is what we get. So the other thing that you could have put would be like the middle of the range. And for this, you don't need to know what the calculation is. You can just look at the scores and pick the middle of the range. I think durable goes from 0 to 100, and it's not in the code book. I'm not sure why, but the middle is probably 50. So you could also use these cutoff points. Now this matters because as you select your cutoff point, and note you don't have to calculate each of these. I'm just giving an example, but whatever you pick, you need to justify, because it's going to change the outcome of the analysis that you do. So if you pick a cutoff point of 3, the countries that are going to be above 3 and the set of countries above 3, the set of countries below 3 will be very different than the set of countries above 6 and below 6, or above 0 and below 0. So this is an analytical choice that you're making that's separate and apart from the statistical choice you're making. The statistical choice we already know is going to be a chi-square test because we're converting all these to categorical variables. But the meaning of those statistical results matter based on how these groups are formed. And we are in the process of forming groups. So to do this, I need to create a new variable, a dichotomous version of polity, which I'm going to call polity D for dichotomous, and durable D for our dichotomous durable variable. And to do this easily, and there are lots of ways you could do this manually, but Excel provides you with a function that makes this relatively easy. When you hit equals, there's a function called if. So when you start your parentheses, it actually tells you right here that you have to enter a logical test, the value if you want it to be, if the value if the logical test evaluates to true, and what you want it to say if it evaluates to false. So this is where you have to be really careful about which direction you call zeros and ones so you don't forget for your analysis. I usually go with ones being the higher numbers and 0 being the lower, or 1 being yes and 0 being no. But that is up to you. You just need to keep track. So the logical test is if this polity score is greater than or equal to mean. I'm going to use median. I like the median one better. Then I'm going to say it's a 1, and if it's less than that value, I'm going to say it's a 0, and that's how this translates. Now, one of the things that you need to be really careful of here is I want this column where it says G5 right here, I want this column here in I to evaluate every value along this whole column in G. But I want it to evaluate it against this specific number, not changing, always this number, this median number. So don't forget that right here around the J, you need to insert $ to keep that value static. Now once you're done with that formula, you can just hit enter. So I want to check it. Here I have 0, and remember I said it should be a 1 if it's above my median, or a 0 if it's below my median. So here I have a -7, that's below my median, and so the value should be 0. And I can write that here how I do it. It's up to you, but 1 is above and 0 is below. So this is a reminder of which groups I'm talking about. So I have this formula that I put into the first cell, and if you haven't done this before, you can just drag this all the way down, and it will populate that logical test for every cell. So note that each one of these tests its respective G whatever row. So here I'm at 12, and so this is comparing G12 against that static median value. So now I'm going to do the same thing for durable. I'll type equals if durable is greater than or equal to my median, then 1, because I'm doing 1s for above, and if it's less than that, I'm going to say 0, close parentheses, and hit enter. And note that if you don't close the parentheses, Excel will complain, but a lot of times it'll fix it for you. So again, I want to make sure that this comparison value, the J value, my median value, is static. So I fixed that with the dollar signs. The dollar signs go around the letter, remember, only, and hit enter. Okay, so I just want to check this. If durable is below my median, it should be a 0. So here durable is 3 and my median is 9, so that looks correct. And I'm going to go all the way down. Sometimes it's helpful to spot check that in case you wrote your if statement wrong. Okay, so now where I'm at is I've done the first step in the data challenge or homework assignment, whatever you're working on with this, and I have 2 dichotomous variables. I have a polity variable and a durable variable. But what I need to do, if you recall from the chi-squared lesson, is to create a chart where I have all of the polity 0, durable 0 counts, all of the polity 1, durable 0, and so it's that little 2x2 table that we used in our lecture. I want to create that here. Now there are lots of creative ways to do this manually, and I mean, one of the ways is to add these values up and then sort them, and that takes a little bit of time, but Excel provides you with pivot tables. So I can select all of this data. All I did was click and drag over the whole thing. And if you go to insert, there's a pivot table option right here. And I can insert a pivot table. I want to put it in a new worksheet because pivot tables are a little bit messy. So I can insert this into a new worksheet, and when I click OK, I am presented with this weird thing. So if you're good at pivot tables, good on you. I'm not good at them. I usually fumble my way through them because I don't use them enough. But here we have the 2 variables that we've been working with, the polity D and durable D. These are the 2 that I highlighted and created the pivot table from. So I want my durable to be, I'm going to put it here in the rows. And I want my polity variable, I'm just going to drag it into the column section. So you see it generates this table for me, and I'm not sure why it doesn't like to name them, but I'm going to name this durable, just so I can keep track. And I'm going to name this one polity. Okay, but these numbers, oops, these numbers aren't right. Sorry, what just happened is that I clicked out of the table and that table disappeared. If you click inside the table again, the box should appear. And if it doesn't, you can go to this pivot table tab, and it's the field list button. So if that's been deselected, you can't see it anymore. Okay, so here though, the problem is that I have a sum of these variable, and you'll remember that when polity is 0 and durable is 0, the sum of all the zeros is going to be 0. So that's not what I want. What I want is a count of how many zeros there are and how many ones in each of those categories. So if I click this little down arrow here, there's a value field settings option at the very bottom of this menu that pops up. And I want to use count, not sum. Now, for lots of other statistical tests, you can use these. This is how I managed the Frontex data for the first few data challenges. The count variable, or the count measure here, allows me to see, and you'll see the numbers change. What I can see here is that it counts how many instances of a durable equals 0, polity equals 0 country there are in my data set, and then a durable equals 0, polity equals 1, durable equals 1, polity equals 0, and then durable equals 1, polity equals 1. So I have 152 countries in the data set, and I have grand totals here. Now, we talked very quickly about the crosstabs example, but this is what we would call the observed. So this is what we actually saw in our actual data set. This is not made up data, this is the real data. What we need in order to calculate chi-squared is the same table, but what we would expect. So if you recall, there was a way to calculate, we used a gender table, right? Male, female, yes, no, and where you guessed 50% of men and 50% of women might be expected, and 50% of yes and 50% of no. And we're going to do the same thing here. This follows a standard formula, and I'm just going to copy these headers really quick so I can use them. I just want the, oh, this doesn't make a table, and I just want these right here. Okay, so the way that you calculate this for each of these is to type equals, and it's going to get a little messy because it's going to be referencing a pivot table, but I'm going to start and try to do one calculation for each square, right? And this is the part of the cross tabulations you have to be very careful about. But right now I'm focusing on this 0, 0 cell right here. So the formula goes row total over total total times column total, because I'm trying to triangulate to this number 44 right here. So I need this number and this number, all including the total, right? So I'm going to do the row total divided by the total total and times the column total, the column that 44 is in, and then I'm going to hit enter. And so I get this number is what would be expected if you knew the total number of durable equals 0 and the total number of poly equals 0. This would give you what you would expect to find. So I need to do that for every cell. Do equals, and then I do row total divided by total total times column total, but this time remember I'm doing the 28, so I need this column total. Enter. Here I have, okay, so now I'm working with this 27 right here, so I need this row total, 80, divided by total total times, and the column total that this 27 is in. Whoops. I think I forgot a parentheses in here. Let me do that over. Okay, row divided by grand total times column. And then again, the final cell. So this is the cell that has 53 in it. I'm going to do equals row total divided by total total times the column total, because I'm here in the 53. Okay, and hit enter. So now I have a table of expected values. And so this is what I actually observed in the data set, but this is what I would expect given these total values, if that's what I knew. Okay, so now to do chi-squared, what I'm trying to do is figure out the difference between observed and expected. Now, really the first thing I should have done is to establish my hypothesis. Recall that H0 is always no difference, or no relationship, or whatever, no nothing, no relationship. Sorry, it's my phone. And in that case, what we're saying is there's no difference in durability. This is actually regime durability, I think. Regime between, and then I have democracy and non-democracy. Now recall here that I defined the limit for where you become a democratic country versus not democratic country at the median value rather than at the split middle. If you do the split middle, which is fine, you can justify it however you want, just make sure that, one, you know that you have to explain that in your analysis, but also that your statistics and probably your hypothesis decision at the end will be different than mine. So the alternative hypothesis is always there is a difference, sort of generic alternative. So in other words, there is a difference between regime durability of democracies versus non-democracies. So when you do your analysis, I would prefer that you don't just write your hypothesis and all this jargon in terms of variables, but that you put it in words that somebody who's not following your statistics could understand. And also recall that in a chi-square test, we can't tell directionality. We can only tell that there is a difference or there isn't a difference. So a hypothesis for a chi-square test, or an ANOVA test for that matter, would never say that, democracies are more durable than non-democracies. We don't know in this instance which one is more or less. We just know that there is a difference. For all we know, non-democracies could be more durable regime types. We can't tell from our hypothesis test. That's not what this kind of test shows. Okay, so I'm just going to, I guess I should have called this expected. I'm just going to copy these headers again so I can reuse them. I'm just creating another table. So I'm going to call this one my statistic. It's probably not a good title. Okay, so the formula for the statistic that we're calculating, the difference between observed and expected, is observed minus expected, all squared, divided by expected. And to make sure that the squaring happens the right way, it should happen the right way, but I don't ever trust Excel. I'm going to use extra parentheses here. But I'm going to have, let's see, so here's my observed table, my first observed value. Now note here, what I'm trying to do is match this 0, 0 column and this 0, 0 column. So right now I'm comparing these tables, this table, observed table, to this expected table. Okay, so I have this value as my observed, right, minus my expected, and this 0, 0, close parentheses. And to square something, you hit the shift 6, which is a little caret, 2 divided by expected. So I'm going to click this 0, 0 right here again and hit enter. Okay, so now I'm going to do that for every cell. So I'm going to do observed, which is, now I'm at this 0, 1 cell, observed minus, and then my expected is here in the expected table, this 0, 1 cell, right, close parentheses, little caret, 2 divided by, and then re-click this red one again, expected. Yours might not be red. And then hit enter. Okay, so I have to do this 4 times. You can see why this is annoying. Here I'm at 1, 0, so I'm going to click 27, minus expected, which is this 1, 0, close parentheses, caret, 2, divided by, and then click the red one again, expected, and hit enter. And then I have observed 53 minus, and here I'm in this 1, 1 cell, expected, close parentheses, caret, 2 divided by, and then click this red cell one more time, hit enter. Okay, so now I have a new table of this statistic, and to get my chi-square statistic, and I'm going to call this chi-square, what I need to do is add up all of these cells right here, everything, doesn't matter which order. So I can hit equals and type sum, which is your additive, and parentheses. Now if I click in this cell right here, I can actually click, hold, and drag to get all 4 of these cells. You can also control click all of them if you want, each individual one. Okay, so close my parentheses and hit enter, and I have this chi-square statistic, which is great and all, but unlike the z-score, I don't have a frame of reference for what's a good chi-square statistic and what's a not good one, because they change. And to do chi-square, you need to have a degrees of freedom. I'm going to call this degrees of freedom. Now remember that degrees of freedom is always number of rows minus 1. So I have 2 rows minus 1. 2 minus 1 is 1. I mean, you can type this out if you want. It's not necessary. 2 minus 1. So that's rows minus 1 times. And then, I don't actually know if Excel lets me do that. And then number of columns minus 1. So I have 2 columns. So 2 columns minus 1 gives me 1 degree of freedom. Any 2-2 table will always give you 1 degree of freedom. Okay, but that's great. I still don't know what that means. I can't picture what a chi-square with 1 degree of freedom is and where we are in that. So what I really need is my magical p-value. And p-value you can get from both of these numbers by typing equals chi-dist. So you'll notice here that this one has a little exclamation point and says it's compatible for Excel 2007 or earlier. It doesn't matter, it'll still work. So type chi-dist, open parentheses, and you'll see here it tells you what it needs. It needs an x, which is your observed, and your degrees of freedom. So we observed an 11.396. I'm just going to click this chi-squared value to fill that in, so I don't have to type it again, and then type a comma. And it highlights where I'm at in the formula right now. So now it says I need degrees of freedom, which I happen to have right here. So I'm going to click that box and close the parentheses and hit enter. Okay, so I'm left with this p-value of 0.0007. Now you'll notice that this may be different than the one I did last night. I think I chose a different cutoff, I'm not sure. But these values right here, all of these table values, the number that falls into each cell, the expected one probably is going to be close to the same, and the count, this statistic one where you've calculated the observed minus expected squared over expected, will all be different if you picked a different cutoff point here. So all of this could be dramatically different depending on what cutoff points. So you can't base your answer necessarily on other people's in the class if they chose a different cutoff point. So here I have these values. I'm just going to highlight for you here and make it a little bigger. I don't know why Excel wants to make everything so tiny. Okay, so here I have 0.007, which means that p is small. So I'm going to reject the null, that this no difference is not true, and that instead there is likely a difference. I'm going to accept my alternative hypothesis, that there is likely a difference, and that some regime durability between democracies and non-democracies is not the same. Which one is better? I don't know. And that's what I get from this. So you could look at these cells and sort of infer which ones are driving the statistic the way it is. You can see here that this number, 3.1, I mean, really all of them are pretty close to off from themselves. But here I have 42 and 53. It's like a spread of 10. 38, 22. I mean, it looks pretty even. So it's hard to tell actually from this one which cell might be driving it, whether it's durable democracies or non-durable non-democracies. It's hard to know because they all actually are pretty far from their expected values. So this concludes the data challenge that we did in class on October 6th, and I'll rename this sheet and put it up for you so that you can follow along in the sheet if you want to. I'll call this durable democracy, and I'm going to move it after the data set. So you can look at this class example here where instead, and this is from last year or the year before, but instead of median I used the average polity and durable score, and I did not use pivot tables. So what you see here is that there's a sort of tricky way of doing sums to figure out which one fits where. And you'll see also that because of the way I chose my cutoff values, that I was not able to reject the null hypothesis, right? This p-value is very large, And so I would have gotten that there's no difference between the groups. So I'll keep this in here, but without explanation, only that this is a version that I did in a previous year where I chose a different cutoff, which leads you to a different outcome. And that's where I caution you as you check with other students and you work together, that you can get off from the very start if you've chosen a different starting point. So you may follow, obviously you're going to follow the same procedure, but that your end result may be different. And what's important in that is that the statistics aren't lying. You've divided the groups differently. So depending on how you define a democracy or a durable regime type based on these cutoff values will dictate whether or not the groups are different from one another, right? I mean, the polity expectation here for durability, or for polity, is much higher than that of the average, and certainly that of the middle, right? This is significant, especially when the score only goes up to positive 10. So this polity score here is actually pretty stringent. Whereas the average durable versus the middle and the median are significantly different. So you can see the groups would divide differently, leading you to a different result, which is why your analysis really should include some interpretation of this hypothesis statement framed by your cutoff choices and what countries maybe fall in that cutoff that make you suspicious of that cutoff or made you choose it, and what might not. And I mean, alternatively, you could do the same test for two different cutoffs and talk about the differences. So I hope that helped, and I hope it's slower and maybe a little bit clearer than the one I offered at the very end of class on Tuesday.